Hello, myself Dr. J D Kalyani, working as Associate Professor in the Department of Computer Science and Engineering of Institute of Aeronautical Engineering. In this video, I will discuss the question bank of Module 4, that is regarding input-output organization and memory organization. The first question is, explain with the block diagram the DMA transfer in a computer system. The peripheral devices can provide the system with the interaction with the outside world. So both the input devices and output devices combinedly can be referred as peripheral devices. So they are used to transform the binary information from outside world to the system and from system to the outside world. So the mode of data transfer is of three types. One is programmed I/O, second one is interrupt initiated I/O, third one is DMA. In the program initiated I/O, with the help of software instruction, the status register can be checked whether there is an input for the system or not. Then only the data transfer can be take place depending upon the status register flag. In the interrupt initiated I/O, the devices that need the input-output can raise the interrupt so that the CPU can temporarily suspend the task execution and can serve for the peripheral devices. So this type of input-output operation is generally referred as interrupt initiated I/O. The third method is DMA, direct memory access. So to increase the speed of data transfer, to minimize the CPU intervention regarding the input-output transfer, the DMA method is preferred. So the data transfer between fast storage media such as magnetic disk and memory unit is limited by the speed of the CPU. So the peripheral devices directly communicate with the memory by removing the intervention of CPU. So this type of data transfer is referred as DMA, direct memory access. During DMA, the CPU is idle and has no control over the memory buses. So here a DMA module is responsible for the initiation of the DMA data transfer. When large volumes of data are to be moved, a more efficient technique that can be used is the DMA. DMA involves additional module on the system bus called DMA module. So DMA modules transfer data to and from memory over the system bus. The DMA module must use the bus only when the processor does not need it, or it must force the processor to suspend operation temporarily. So here to acquire the CPU attention, the input-output devices can require the DMA controller. The DMA controller is used special control signals. So during DMA transfer, the CPU is idle and no control over the system bus. The DMA controller takes over the buses to manage the transfer of the memory buses. So two control lines can be used for this purpose. One is bus request, second one is bus grant. So whenever the DMA transfer can be initiated, the DMA module can issue the bus request signal so that the CPU can place the data bus, address bus, read-write signals in a high impedance mode so that a open circuit can be formed and no control over the buses by the CPU. So after keeping these buses in the high impedance state, the CPU can issue the bus grant signal to the DMA controller to indicate that the DMA can involve in the direct data transfer, so that the DMA controller can have control over buses and involved in the data transfer without intervention of the CPU. So here two control signals can be used by the DMA controller. One is bus request, which is generally referred as BR. Second one is bus grant, which is designated with BZ. So here the bus request signal can be initiated by the DMA module in order to acquire the control over the buses and to relinquish the CPU. So after relinquishing and keeping the buses in the high impedance state, the CPU can issue the bus grant signal to the DMA controller. So what is the bus request control signal? The bus request input is used by the DMA controller to request the processor to relinquish control of the buses. So all the address data bus, all buses can be kept in high impedance state in order to disconnect CPU from the buses. When the input is active, the CPU terminates the execution of the current instruction and places the address bus, data bus and read-write lines into a high impedance state. The high impedance state behaves like an open circuit so that the DMA controller can take the control of the buses and involve in the data transfer. What is the bus grant control signal? The CPU activates the bus grant output to inform the external DMA that the buses are in high impedance state. So the CPU can be disconnected from the buses by keeping all buses in the high impedance state. This state can be indicated to DMA controller with the help of bus grant control signal. The DMA that originates the bus request can now take the control of the buses to conduct memory transfers without processor intervention. When DMA terminates the transfer, it disables the bus request time. So CPU disables the bus grant, takes control of the buses and returns to the normal operation. So thereby the DMA controller uses two control signals in order to control the data transfer between peripheral devices and the memory. Those control signals are bus request and bus grant. So what are the modes that are supported by the DMA transfer? There are three types of modes. One is the burst mode, second one is cycle stealing mode, third one is transparent mode. In the burst mode, the DMA hand over the buses to the CPU only after completion of whole data transfer. So entire data transfer completion after only the buses can be given to the CPU so that the CPU can be idle during the transfer time. So wait time for the instruction execution can be increased in case of burst mode. The second mode is cycle stealing mode. In this mode, DMA gives control of buses to CPU after transfer of every byte. So after transferring every byte of data, it can give the control of the buses to the CPU so that CPU can carry out the execution of the instruction. And again it can acquire the bus control so that it can transfer the next byte of data. So that here the request signal and grant signals has to be frequently used to access the CPU attention and to gain the control over the buses for data transfer. But here CPU does not have to wait for a long time if it needs a bus for higher priority task. So here higher priority task can be executed by gaining control of the buses from the DMA controller after every byte of transfer. So that type of mode is referred as cycle stealing mode. And the third mode is transparent mode. Here DMA transfers data only when CPU is executing the instruction which does not require the use of buses. So here where the CPU is concurrently executing the instruction and DMA can involve in the transfer of data in the transparent mode during the time that CPU does not require buses, then only the DMA controller acquire the control of buses and transfer the data in transparent mode. These are the three modes of data transfer in the DMA. And here DMA uses special registers. One is the address register. It contains the address to specify the desired location in the memory, and word count register, which is used to indicate how much length or number of words that can be transmitted. So it contains the number of words that can be transferred, and the control register that can specify the transfer mode. And this is the DMA controller, the block diagram of DMA controller. So here the special address register is used to point the location of the memory, and address bus buffer can hold the address, temporary address, and the register can carry the location. Word count register can hold the number of words that can be involved in the data transfer. Control register is to indicate the status of the data transfer, and this data bus buffer can hold the data to be transferred, and here uses the bus grant and bus request signals BR and BZ in order to gain control for the DMA controller. The control logic can be used, and what operation to be performed, either read or write operation, the control lines, and data select and register selection lines can be used to select the particular registers. So depending upon these control signals BR and BZ, the DMA can gain the control, and with the help of this control register and one count register, the data, how much data is to be transferred, can be determined with the help of these two registers. And this is the circuit diagram of DMA transfer. So here this is the memory and CPU, and this is the DMA controller, and these are the IO devices. Whenever IO devices require the service of the DMA, they have to use the DMA controller and grab the attention of CPU by raising the bus request signal. Okay, so that the input device can be activated, can actively involved in the data transfer. So that the CPU, while during the transfer of data, the CPU can keep all these buses, read, write, address data buses in the high impedance state. So this is the DMA transfer. What are the advantages and disadvantages of DMA transfer? So DMA speeds up the memory operations by bypassing the involvement of the CPU. The control over the buses can be gained by DMA controller during the data transfer. The work overload on the CPU decreases. For each transfer, only few number of clock cycles are required. So all these are the advantages of DMA transfer. What are the disadvantages of DMA transfer? Cache coherence problem. Frequent accessing locations can be done with the help of DMA, which can involve the cache accessing and cache coherence problems, and increases the price of the system. So these are the disadvantages of the DMA. Next question. Explain about input-output processor organization in detail. So the input-output processor is a specialized processor which loads and stores data into memory along with execution of IO instructions. So here, whatever the peripheral devices that are connected to the CPU can be connected via the buses through the one special interface for each device. So these interfaces for the peripheral devices can be handled and controlled by the input-output processor. It is just like a CPU which is used to schedule the input-output devices that are involved in the data transfer. So with the help of IO instructions, the input-output processor can activate the necessary input-output device. It acts as an interface between system and the devices. So the IOP is a sequence of events to execute IO operations and then store the results into the memory. So how the IOP can be connected? So all these are the peripheral devices. They are connected via the IO bus to the input-output processor. And so this processor can involve by issuing the input-output instruction to the peripheral devices. So IOP behaves like a CPU and can be involved to control the peripheral devices. IOP is similar to CPU except that it is designated to handle the IO processing. IOP can fetch and execute its own instructions. IOP instructions are specifically meant for IO transfer. So in addition, IOP can perform other tasks like arithmetic, logic, branching and code translation. So IOP is a major interface between the input devices and the computer, CPU and memory. How the communication between CPU and IOP can be take place. First, the CPU can send an instruction to test the IOP path, whether the path is available or not. Then the IOP can transfer status word to memory location. So it can, after the path is available, the IOP can involve in the transfer of a memory word. If the status is broken, send start IO instruction to IOP access. So the IOP can access the memory for IOP program and conduct the IO transfer using DMA. In the meanwhile, the CPU continue with the other program parallelly and the IOP can involve the data transfer with the help of DMA without intervention of the CPU. And IO transfer completed, interrupt the CPU to indicate that completion of data transfer. Request IOP status, transfer status word to the memory location, check status word for corrected transfer and continue. What are the advantages of IOP? The IO devices can directly access the main memory without the intervention by the processor. So just like the direct memory access, DMA can be used. But it is used the address problems and cache coherence problems of DMA can be mitigated with the help of the input-output processor. Next question, compare DRAM and SRAM. So here the RAM is the primary memory that is available in the computer. So the primary memory can be connected directly to the CPU. The main memory holds data and the programs that are needed by the CPU. The main memory consists of RAM, which is available in static as well as dynamic variants. So RAM is volatile in nature. That means the content of the memory can get erased when a power interruption occurs or when you switch off the system. So here RAM is expensive and it can be accessed directly. RAM is fastest memory, therefore it is an internal memory for the computer. And here two types of RAMs are available. One is static RAM, second one is dynamic RAM. This circuit describes the design of the RAM. So here the data lines that are required for the RAM are K address lines from the address bus so that the memory address space can be 2 power K words. And to perform To support both operations, read as well as write, two signals, read and write signals, can be connected to the RAM. And n data input lines to the RAM, so that the number of bits per word can be the n bits per word in the memory. And n data output lines can be come out of the RAM. So the RAM can involve in performing two operations, both read operation as well as the write operation. And this is the RAM chip. So RAM chip can involve the chip selection lines CS1, CS2 and read and write operation, and the address lines, 7 lines of the address bus and 8-bit data bus. So whenever the read is activated and the chip is selected, then only the read operation can be performed. And when the WR signal is activated, chip 1 is selected, then only the write operation can be performed. So two variants are there in the RAM. One is SRAM, second one is DRAM. So here SRAM means a bit of data is stored using the state of flip-flops. So SRAM is constructed the main electronic component of flip-flop. Retains value indefinitely as long as it keeps the power. So thereby the RAM is a volatile in nature. Mostly uses to create cache memory of the CPU. So here the cache memory can be the small high-speed memory that is placed between the CPU and the main memory. So faster and more expensive than the DRAM, the static RAM. And one memory cell of static RAM can be constructed with the help of 6 transistors. What is DRAM? So each cell stores bit with a capacitor and the transistor. So the major electronic element is the capacitor. Large storage capacity. So need to be refreshed frequently as it is using the capacitor as the major electronic component. Used to create main memory, slower and cheaper than the SRAM. And the structure of the DRAM is like this, with the capacitor and the transistor. The storage cell can be constructed. The differences between SRAM and the DRAM. The static RAM can be made up of flip-flop, but the dynamic RAM is made up of capacitors. Static RAM is large in size, but dynamic RAM is small in size. The data stored in the form of voltage in case of static RAM, but in the form of charge in case of dynamic RAM. Much expensive as compared with the dynamic RAM, the static RAM. The cheaper one is the less expensive, the DRAM. Low storage capacity for the SRAM. High storage capacity for the DRAM. Consumes more power the SRAM. Consumes less power the DRAM. Fast the static RAM, slower the operations of the dynamic RAM. Data sustained with time, but data losses with time, need refreshing of the circuit, the usage of capacitors. So these are the differences between SRAM and DRAM. Explain strobe control in asynchronous data transfer along with handshaking problem. So there are two types of data transfer generally involved. One is synchronous, second one is asynchronous. If two units are involved in the communication, if the source and the destination can use the same clock for the communication, then that is referred as the synchronous. If the units that are involved in the communication uses different clock signals, then that data transfer is generally referred as asynchronous data transfer. So asynchronous data transfer between two independent units require the control signals to be transmitted between the communicating units to indicate the time at which data is being transmitted. So two types of asynchronous data transfer can be available. One is Strobe method, second one is handshaking method. So the internal operations of a computer is synchronized with the help of the common clock pulse generator. So clock pulses are applied to all registers within a unit, and all data transfer among internal registers occurs simultaneously during occurrence of the clock pulses. If the registers of the I/O interface share a common clock with the CPU registers and the I/O interfaces, then that type of transfer is generally the synchronous. If it all different clock can be used for the data transfer to activate the CPU registers and I/O interfaces, then it is referred as asynchronous data transfer. So two methods of asynchronous transfer can be involved. One is Strobe, second one is handshaking. What is the Strobe? The Strobe control method employs a single control line to time each transfer. So Strobe may be activated either by the source or destination. So thereby two methods are involved. One is source initiated strobe, second one is destination initiated strobe. What is the source initiated strobe? So this is the special signal, this is the strobe control signal. So it is raised by the source unit to the destination unit. So it is a source initiated strobe. So the data bus can carry the data, but this data transfer can only carry during the strobe control line. So the valid data can be transmitted as the strobe is initiated by the source. So this data transfer can be illustrated with the timing diagram. Next, the destination initiated strobe. So here itself the destination unit can send the strobe control signal to the source, and the data can be valid data can be transmitted during the strobe control pulse only, and the strobe can be initiated with the help of the destination unit. Thereby it is referred as a destination initiated strobe. The second control signal in asynchronous communication is handshaking. So the strobe method has the disadvantage that the source unit that initiates the transfer having no idea that whether the destination is received the data that is placed in the bus or not. That's why another special control line can be used in the handshaking. So the handshaking method solves this problem by introducing a second control signal that provides a reply to the unit that initiates the transfer. So here also two methods are there. One is source initiated handshaking. Second one is destination initiated handshaking. So here in the source initiated handshaking, first the source unit places the data on the data bus, enable the data valid signal. So source can keep the valid data on the data bus, enable the data valid signal. Then the destination unit is ready data from the bus, enable data accepted, so that the data accepted signal can be transmitted from destination unit to the source unit. So disable data valid, invalidated data on the bus, so that the transfer can be involved and the transfer can be taken place. Disable data accepted, ready to accept the data, so that the destination can disable the data accept and ready to accept the next data. In this way, the source initiated handshaking can be worked, and the unit that can be receiving the data can intimate the status of the transfer with the help of data accepted signal. The second method of handshaking is destination initiated handshaking. So in this method, first the destination unit is keep the ready to accept data, enable ready for the data, so that the source unit can place the valid data and indicate the data valid signal. So here ready for data can be sent by the destination to initiate the communication. Then the source unit can place the data on the data bus and activate the data valid signal. So accept data from the bus, disable ready for data, so that the destination unit disable data valid and invalid data on the bus and ready to take the next data from the destination unit. So in this way, destination initiated handshaking can be work. So these are the references used in this video. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.